Alright guys, so today we're going to talk about binary compounds. Okay, over here we would have what we would call a binary crime fighting duo, in that there is exactly two people in that team. Okay, so what's the point of today? We want to understand the term binary compound. We want to be able to name, I should be on there. Alright, name them. We want to be able to name binary compounds. And we want to use the valency, see that one's back, to predict the chemical formula of binary compounds when we're talking about metals and non-metal combinations. Okay, and over here, I don't like to explain the jokes. I figure if you get them, you get them. If you don't, you don't. But do you want to hear a joke about nitric oxide? The formula for nitric oxide is NO. It is a binary compound. Alright, so what does that mean? A binary compound is a compound that has first off, what's a compound? Just to make sure you're on the right page. It's a molecule where you have two or more elements chemically combined. Now, what's a binary compound? A binary compound is any compound that has exactly two types of elements. I'm an idiot. Two elements. Okay, so it's got exactly two elements. Now, when the two compounds, done it again. So when the two elements being joined are metals and non-metals, they form ionic compounds. So ionic compounds are a bit more complex than the other types, so we'll stick with these for the moment. These are repeating lattices of fixed ratio. Now, a lattice just means the 3D structure, straightforward. Here we see a 3D structure of sodium and chloride, or chlorine, in fixed ratios. And what this means is you've got repeating structures, so we've got this, that, and it just repeats over and over. In fact, the basic structure is that box there, that first, includes that one there. How do I go around that? Anyway, that first box there, okay, so that's your repeating lattice, and you see you've got ones off to the side, and away we go. Now, these can be simplified to a ratio of atoms. For example, and the ratio is determined by their valency, and we write it as a chemical formula. For example, for this, we have, for every one sodium, we have one chlorine, which means we write the formula for it as NaCl. Okay, you don't need to write the one down here and the one there. That's implied. You only write the number there if you have a 2 or 3 or 4 or 7 or 5 million. You write it, if it's just a 1, you don't write it down. Okay, so we'll bring our eraser back to get rid of that, and that is how that is written every time. Now, for example, if we've got magnesium and chlorine though, for every magnesium there are 2 chlorines, which means we write it like this: 1 magnesium, 2 chlorines. We write it down the bottom here, what we call subscript MgCl little 2. Alright, so naming binary ionic compounds. So back over here, ionic compounds are there we go, metal and non-metal together. Okay, so ionic compounds, we name those with the metallic element first. Cool. We follow this up with the name of the non-metallic element. Alright. The name of the non-metallic element is altered by changing the suffix of the element to "-ide". Okay. So if we go back here, NaCl is sodium chloride. MgCl2, magnesium chloride. So can you write that down there as well, please? So the metal goes first, non-metal second, and we get rid of the end of it, and we put an "-ide", like IDE, on the end. Okay. All right. So boom. Now, naming binary covalent molecular compounds. Okay, so covalent molecular. What this means is we make a compound that has a non-metal and a non-metal, or like 30 non-metals, but non-metal, non-metal. Okay, so covalent compounds are named very similarly, but there are two main differences to ionic compounds. First, the element in the leftmost column of the periodic table, that's named first. So no metals present, so we go whichever one is most like a metal, and that's towards the left. If they're both in the same column or same group, whichever one is lower down is named first. Okay, so I don't have any examples here off the top of my head. All right, if fluorine and chlorine combine, because they're both in the same table, it would be chlorine fluoride. And the reason is chlorine is further down, fluorine's up the top, chlorine's like second down. So that's how that would go. So the metal furthest to the left. So if you're over this way and over that way on the periodic table, you get named first. We put Greek prefixes on the front. Okay, here a sec. I've skipped out a step here. Yep, I skipped out a step. So name the element first. The second element or more of it gets this IDE on the end there still. Okay. But then things get a bit Greek. We start using the Greek prefixes over here to tell you how many of each element there are. Alright, so just to recap that. Most metal, so left down, that's the one that gets named first, and you just use the whole name. Okay. The less metal one with binary compound, that one has the IDE at the end, same as before. So all binary compounds end in "ide." At the beginning of both of those, both words, like the first and the second, you put on the Greek prefix. If there's 2 of something, it's di. 3 of something, tri. 4, tetra, penta, hexa, hepta, and so forth all the way down. Okay, so that's how that works. Now, mono, you don't need to put it for the first one, so you don't go monocarbon monoxide or monocarbon monoxide, but you do go carbon monoxide. If it's more than one though, so over here, if it was dicarbon monoxide, so C2O, then you would put the di on the front. Alright, so here's a little summary, very quickly. Get rid of that, don't need that, that's gone. Binary compounds, non-metal plus non-metal, more metallic element to the left, gets named first, and use the prefixes. If it's a group 1, 2, 3, or 4 metal, the metal ion goes first, and we put "ide" on the end, straight ahead. This one here, you don't need to know so much. We'll get to that in class. That's a deeper conversation. All right. Get rid of that. Now, valency and ionic compounds. How does this work? First, we use valency to determine the combination of elements into new ionic compounds. Valency doesn't so much come into it, does, but not in a way we're going to talk about. So valency doesn't come into it in covalent compounds. Valency is, we use it when we talk about ionic compounds. Alright, so we can use it when writing chemical equations to predict products. We use the crossover method. So if the equation was calcium plus iodine gives us, how do we do it? We go, well, calcium has a valency of 2+, iodine has a valency of 1-. You don't need to write these in your final product, but we cross it over. So we put the 1 down here, 2 there. Okay, and this gives us C, calcium, iodide. Now again, we don't write the 1, we just leave it off. That's how it works. That's the crossover method. Now sometimes it gets a bit more complex. Lead 4 sulfide. Now if you see here, we go Pb, and it's 4 plus sulfur, which is 2 minus. Now if we do the crossover, what that actually gives us is Pb 2s4. But remember how we said it's the simplest whole number ratios? Well, that's not the simplest ratio. That's 2 to 4. 2 to 4, if we simplify it, gives us Pb S2. A way to think of that is 2 over 4. If we simplify that fraction, it's 1 over 2. Alright, that's it. So that's where we end today, and I'll see you in the next lesson.